Um, Alright, what we're gonna learn today is arithmetic sequences and series. And for an example, we're gonna have that's an example of a pattern, of a arithmetic pattern. And we have a bunch of equations for it. We have one to find the common difference. And that one is and these ends are for the term we're looking for. And this is for the term before. We have an equation to find any of the terms. And that one is, and remember that's a term. A1 is for first term. And the last is for finding the sum. And the sum of the first 5 terms. And here's our example. We've got 3, 6, 9, 12, 15. And as you can tell, our difference between each of these is positive 3, positive 3, positive 3, positive 3. So we're going to make a note of our common difference. And if you can remember from the equations I showed you previously, to find a certain term, our equation would be and D always stands for our common difference. So we're going to put a positive 3 right here. And N is the term that we're looking for. And since we're looking for the 12th term, we have to plug in a 12 right here, minus 1. And A, since we're looking for 12, once again, you need to put 12. And A1, the 1 represents the first number in the pattern. And in this case, it's also 3. So our formula to work it ends up being A12 equals A3 plus 12 minus 1 plus 3, positive 3, so we can get rid of that. And once you work everything out, 12 minus 1 equals 11 times 3. 11 times 3 equals 33, and that times a third, which is 3. 33 plus 33 equals 36, and that's your answer for the term you're looking for. And if we want to find the sum of the first 5 terms, the equation I gave you was alright, and since we're gonna have to plug in the numbers that go here, and since this is the sum of the first 5 terms, the number you're gonna have to put in for n is 5. It doesn't always have to be 5. You can find the first 6 terms, however many terms you want, but in this case we're gonna do 5. So you put S5 equals, and this once again will be 5. And A1, like I said previously, A1 is always the first term, which in this case is 3. And AN is the first 5 terms, so you're going to put 15 and then divide it by 2 to To simplify this, you're going to have to put 18 divided by 2, which gets you 9. You bring down this 5 and put the 9 here, and that gives you 45. And that's the sum of our first 5 terms. Now we have geometric sequences and series. Now geometric sequences and series are different from arithmetic because it's not simply just an adding or subtracting to find your pattern. It's actually like multiplying and dividing. So here's our example, and as you can see, it's no longer common difference, it's considered a common ratio. And in this case, to get from 2 to 4, you have to multiply by 2. To get from 4 to 8, you have to multiply by 2. 8 to 16, multiply by 2. So our common ratio would be 2. And our equations for the geometrics are to find any term is, and n stays being the term you're looking for, or anything. In that way, it's the same as the arithmetic. Once again, it's the first term, because it's A1 for first term. And then R is the common ratio. N minus 1. And to find the sum, is Sn remains the same, and then first term 1 minus the common difference in the term, and then 1 minus common difference. Sixth term, we're going to use the equations I gave you. In this case, it was and it's simple here to find the ratio. It's once again it's multiplied by 2. That's 8 times 16, 4 times 2, 8 times 2 equals 16. Now plugging everything in, A will be to the 6th power because we're looking for the 6th term. And then A1 is the first term, which is 1. So you just bring this down to a 1. And R, which is the common ratio, is 2. N minus 1. So we're looking for the 6th term, so you're going to plug in 6 minus 1, which will turn into a 5. So it's 2 to the 5th power. A equals 6. A6 equals 1 times 2 to the 5th power. And working this out, we get 2 to the 5th power, which is, and 2 to the 5th power equals 32. So we're going to have 32 over here. 1 times 32. A6 is for the 6th term. 1 times 32 obviously is 32. So that'll be our answer. And to find the sum of the first 5 terms, we're going to use Sn equals A1, 1 minus the common ratio, which is R, to the first, or whatever term we're looking for, which in this case is the 4th term. We're not doing 5 anymore. Divided by 1 minus, once again, the common ratio. And plugging in the numbers, A1 is the first term, so we're going to plug in 1, first 4 terms. And in the parentheses, we're going to put 1 minus common ratio, which is 2 to the 4th power, over 1 minus the common ratio of 2. And 2 to the 4th power is, we're going to plug in our numbers. It's 1 minus 2 to the 4th power, which is 16, over 1 minus 2, which is negative 1. 1 minus 16 gives you a negative 15 over a negative 1. And simplifying that, you can see negative 15 over negative 1 equals 15. And the sum of the first 4 terms is now 15. And to check it, we can go up to our example and add 1 plus 2 plus 4 plus plus 8. 8 plus 4 is 12, plus another 2 is 14, plus that 1 is 15. So we have our answer.